Hey, what's up, everybody? It's Dan from SageMathTutoring.com, and here I have another review sheet for a student of mine. She is an 8th grader, and this is a geometry class. So I'm just going to go through some of these problems that she sent me that she had questions on. Now, I'm not so sure if she had questions on this. She typically circles the problems, but nonetheless, I'm going to do the whole thing really quickly. And I'm going to kind of run through this quickly because this YouTube video probably going to be helpful for a lot of people, but it's mostly geared towards my student. And I already know my student's ability. She's actually really good at math. So it's just probably little refinements along the way. But nonetheless, here we go. Find SR. Well, SR is the length between point S and point R. Whenever you're dealing with like the number line scenario like this, you always want to take this larger number and subtract the smaller number. All right, so you just kind of follow that algorithm and it'll work every single time. So that would be 9. So that's that one. Let's see, name, also known as C, name the coordinate of the midpoint of BC. Well, BC is right here. Okay, so if you want to find the midpoint, that's a little bit different. You take the two numbers involved. In this case, it's B and C, so it's like -4, and you actually add the other number, which is a -1, and then you divide the result by 2, and that's going to be -5/2, and if you sort of went through the motions, you would realize quickly that that is C. All right, so this one's C also. All right, so let's see. Refer to the figure at the right for questions 3, 5. All right, first off, how many planes are shown in the figure? I would start with just taking the top and bottom into account. So there's the top, which is 1, there's the bottom, which is 2. And then what I would do from there is I would take into account that there's 2 so far, so we could even do like a tally, right? And then I would take into account the edges of the top just to avoid confusion. That's 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, 5. We are looking at 7 planes. All right, looking at number 4, name the intersection of planes ABG and CHG. So ABG is right there, and CHG, where is that? That would be CHG. Okay, so they intersect at BG. Okay, so ABG is this plane that's kind of off to the side behind a little bit. CHG is this plane that's in front, and they clearly intersect at BG. All right, so let's see. I guess the question is it segment BG or line BG? That's kind of a tricky one. I would say that it's line BG because planes, my understanding at least, and my student should just sort of double check this in her own mind, but my understanding is that planes go on forever in all directions, and since even though it looks like it's like this finite shape, it actually goes on forever, and since this plane goes on forever, this plane goes on forever, and all the planes go on forever, this BG would also go on forever. And obviously we can't draw a plane that goes on forever because you'll run out of paper. But planes are such that they go on forever unless otherwise indicated, so I would choose D for that one. I would ask my student to double check with her teacher about that to ensure that we're on the right track with that. That could be an idiosyncratic thing when it comes to the teacher. All right, looking at number 5. Name the intersection of plane ABC and HL. So HL, let's see, where would that be? Okay, it looks like HL is this line that's like in front. All right, so L looks like it's in front. And the intersection of ABC, this plane, and line HL. Well, this line, since it goes on forever, it intersects this top plane at point C. So ABC is the top plane, and HL is this line right here. So it intersects at this point C right there. So that's the answer. Okay, find the measure of BE if C is between B and E. Okay, so BE, where is that? BE. I made the mistake of thinking that we're dealing with this. We're actually not dealing with this problem anymore. This problem only refers to 3 through 5. So 6, find the measure of BE if C is between B and E and BC equals 17 and CE equals 6.5. So it's always good, or often good, to draw the situation. So we have certainly, a B, we've got E, and apparently C is in between, so C is right there. And BC, according to the information, is 17. And CE is 6.5. So that's right there. And we want the measure of BE. Well, that's the segment addition postulate. That's going to be 17 plus 6.5. And 17 plus 6.5 is definitely going to be 23.5. All right, which term applies to two segments that have equal lengths? They would be congruent, okay? So if you have two segments that have equal length, congruent. And for my student, just be on the heads up, shapes or geometric figures, one way or the other, that are congruent, that basically means they're the same size and shape. So that word congruent applies to that which is the same size and shape. All right, 8, what are the coordinates of the midpoint of the segment with endpoints, blah, blah, blah. Okay, midpoint formula comes into play with number 8. Midpoint formula is something that is definitely worth memorizing, and here it is. Here's the midpoint formula. You're going to have to memorize that. You're going to have to memorize the distance formula also. All right, so there's x1, x2, y1, y2, and this is assuming you have 2 points. All right, assuming you are given 2 points, and that's going to be x1, y1, that's going to be x2, y2, and then you just apply this. All right, so let's take a look. We've got, pretty sure my student knows how to do this, but I'm just going to do it real quick. I always like to draw empty parentheses and then fill them in with whatever belongs there after. That's kind of a systematic way of going about it. In my opinion, the more you can get in the habit of going about things like systematically, the better, because it saves RAM on your brain, if that makes any sense. -2 and 1.5. So -2 and 1.5. This right here would be -0.5 over 2, also known as -1/2 over 2, also known as -1/4. And the only answer that features that is this one right here. So that's the answer. I don't care about the rest of the calculations. All right, if two complementary angles have measures of 4x plus 14 and 3x minus 22. All right, so number 1 is complementary. Once again, it's a good idea to draw the situation. Complementary angles feature a 90-degree angle, and usually we have some other ray popping out like that. That's a ray, that's a ray. Also, so even if it's not drawn to scale, whatever, this is sort of a generic complementary angle situation. It can't hurt to just draw this and then proceed from there. The complementary angles have measures of 4x plus 14. So here we go, 4x plus 14, and the other one has 3x minus 22. All right, now they want to know, the smaller angle has what measure? Well, I think this is probably going to be the smaller angle, but you got to be careful. Let's just find x first, and then we'll worry about what the smaller angle is later. And the way to find x in this case is to recognize that if these angles are complementary, then we should be able to hypothetically set up the following equation. And that equation would be this: 4x plus 14 plus 3x minus 22. Well, that equals 90. Combining like terms gives us 7x, and then we have minus 8 equals 97x equals 98x, therefore equals 14. The fact that it is a nice whole number, an integer, is a good sign. Okay, since 14 is positive, since x is positive, then we know that this is the smaller angle, because 3 times a positive 14 minus a whole bunch of stuff. It's definitely going to be less than 4 times 14 plus a whole bunch of stuff. So this is the smaller angle, so we're only concerned about that when we do the final calculation. So we're looking at 3 times 14 minus 22. 3 times 14 is 3 times 10, which is 30, plus 12, which is 42. And that's going to be 42 minus 22, and that equals 20, so therefore the answer is 20. All right, moving on. Okay, so we have 5 times the measure of an angle is 48 more than the measure of its supplement. So, okay, so if the angles are supplementary, then the first angle we could call x. And this might be a little different than the way that my student's teacher teaches it. But nonetheless, hopefully my student understands this. So the supplement, if x is the angle, then the supplement is going to be 180 minus x. Right? Because x plus the supplement equals 180. So whatever the supplement is, it's going to be 180 minus x. So that's a way of thinking about it. And basically, you could set up an equation based off of what they say here. So we have 5 times the measure of an angle. So that's 5x. And then it says is. Now is, in algebra land, means equals. So 5 times the measure of an angle is 48 more than the measure of its supplement. So the measure of the supplement, we already know, is 180 minus x. I'll just put it in parentheses for now. And then it's going to be 48 more than that, so that's plus 48. Again, that might be a little bit different than the way that my student's teacher teaches it, but this is a good, valid way of going about this. X is the first angle they're talking about. The measure of an angle, that's x. We know that the supplement is one of the stars of this show, so we're going to create, an expression representing the supplement, 180 minus x, and then you just kind of translate the sentence. 5 times the measure of x is 48 more than the measure of its supplement. So then you could take it from here. On the next line, it's 5x. Now, we don't really need these parentheses. I just used them to sort of separate them out. So I'll actually just write it without the parentheses. And we have 5x equals 100. That's going to be 228 minus x, adding x to both sides gives me 6x equaling 228x. Therefore equals, after dividing 228 by 6, is 38. So let's see. Find the measure of the angle. Well, the angle is x, and we just solve for x. So you want to be careful at the end. Make sure you're actually answering what they're asking for. So I hope my student realizes that for the test, it's a strong possibility the teacher's going to be really tricky when it comes to what they're asking for. Be sure you're aware of what they're asking for. Make sure you answer that question. The angle we had already represented as x, so we just solved for x, and now we're done. Again, warning, just because you've solved for x doesn't always mean you're done with the problem. Okay, so we want to find a. Well, a is right here. A is the following. A is definitely going to take on the x-coordinate of this x-coordinate, so that's going to be -4. And it's going to take on the y-coordinate of this y-coordinate right there, so that's 9. Okay, so we just found it. I'm not going to write it. Find C. C is down here. C is definitely going to take on the x-coordinate of this thing, which is 8, and it's going to take on the y-coordinate of this one, which is 3. All right. So the reason for that is because the x-coordinate corresponds to how much to the right or to the left on the xy coordinate plane A is, and the number that represents how much to the left or right A is this x-coordinate. The reason why, the y-coordinate of A is 9, because y-coordinate of any point has to do with how far up or far down a point is on the xy coordinate plane. And in other words, sort of the height of the point, and the height of this point is given by this height right here. All right, so to my student, I am certain that that's clear. Let's move on. Find the perimeter of ABCD. Well, that would be a matter of adding all the side lengths. All right, there's kind of a quicker way of doing it, but for now, let's keep it very simple. We're looking for the length of the fence all the way around. So let's find this distance. Now, the distance between A and D is the distance between the heights, the 9 and the 3. And the reason why we can use that simplified understanding is because AD is actually parallel to the y-axis in the xy coordinate plane. If AD is parallel to the y-axis in the xy coordinate plane, all you have to do is compare the y coordinates and just find the difference between the two. Now all you have to do is take the larger one and subtract the smaller. 9 minus 3 is going to be 6. So we're going to write that right there. Looking at AB, let's get this right here. So AB is going to be the change in x coordinates. So because notice the y coordinates are the same, so it's really just the change in x coordinates. And the reason why we can use that simplified understanding is because AB is actually parallel to the x-axis. And if AB is parallel to the x-axis, all you have to do is pay attention to the change in x coordinates. And similar to what we did over here, you just have to take the larger x coordinate and subtract the smaller. Now you have to be very careful because this time you have a negative. So it's going to be an 8 because that's the larger x coordinate right there. And you're going to subtract the smaller x coordinate, which is -4. That ends up becoming 12. All right. So hopefully that is obvious to my student. Now here's the easy part. Once you have this, it's a rectangle, so you know for sure that's going to be 12. That's going to be 6. Then it's a lot easier to just add it all up. Let's see. 12 plus 12 is 24, plus another 6 and 6. That's really 24 plus 12, which is 36. So we are looking at a perimeter of 36. Okay, and then they want the area of ABCD. Well, the area of any rectangle is going to be length times width. Well, we have what could be considered the length, that's 12. Let's just call that the length. Doesn't matter which one you assign to the length or width, you just pick one. We'll call 12 the length and the width is 6, and that ends up becoming 72. That's how you do that one. All right, find x right here. What looks like 3x minus 5 and 2x minus 5 are definitely a linear pair. They are supplementary, therefore. So it's going to be 3x minus 5 plus 2x minus 5, and that's going to equal 180 without question. Like terms, 5x minus 10 equals 180. 5x therefore equals 190, and therefore x equals, after dividing both sides by 5, x would equal 38. So that is that one. Okay, looking at the next one, we've got two complementary angles right there. So that's going to be 3x minus 5 plus 2x minus 5 equals 90 this time. Now, if I'm not mistaken, it's the same expressions. Here's the deal. My student is definitely skilled enough to just go through the motions here. That's going to be 5x minus 10 equals 90. I'm going to be a very smart person and realize that it's the same expression as right here, only this is half the amount. So x is going to be half the amount. So x, cutting to the chase, is going to be 19, because 19 is half of 38. That's a quick shortcut based off of this information. If my student is not comfortable with that shortcut, then just go through the motion, solve for x. I know she knows how to do that. All right, looking at this one. Okay, you have multiple options here, or do you? You only have one option, okay, because we actually don't know that there's a 90 degree over here. So we actually only have one option. If this was 90 degrees, then we could be like, okay, this plus this equals 90. That would be an option, but we don't know that this is 90 degrees. So we actually only have one option. And the option that we have is to recognize that this angle and this angle are vertical. So be on the lookout for that, my dear student. This is what's called a red herring. It's designed to bait you into thinking in the wrong direction. This is the vertical angle. That is the correct thing to focus on. So we're going to say that x 8x minus 7 equals 5x plus 20. Subtracting 5x from both sides gives me 3x. Adding 7 to both sides gives me 27. And then we have dividing both sides by 3 gives me 9. We just found 9, and that is that one. All right, use the number line to find the midpoints of the following. Okay, A, B. Well, let's get clear on what B is. B is apparently at -3. Now, anytime I want to find the midpoints, I take the points, I add them together, and I divide by 2. So this is going to be -9 plus -3 divided by 2. Just go through the motions. Once again, take each point, add them together, divide by 2. That is a guaranteed way of getting the midpoint. So we're looking at -12 over 2, also known as -6. That is this one. BD. Helpful to label the point. This is, let's see, 0, 1, 2, 3. Okay, I guess this is 1, 2, 3, 4, 5, 6, 7. I think D is 7, pretty sure. All right, let's take a look. BD, so B is at -3. Okay, so we're just going to go through the motions there too. What do we got? We've got -3 plus 7, and we're going to divide that by 2. That ends up becoming 4 divided by 2, also known as 2. Yay. 2 as the answer. All right. So looking at this one, find the coordinates of midpoint M. Same deal, believe it or not, except now it's at a slant. All right. So if it's at a slant, then it's a little bit more complicated where you're going to have to bust out the actual midpoint formula. The actual midpoint formula will be required for this one. So what is the midpoint formula? The midpoint formula, I think we discussed it already, is this. Actually, we definitely did discuss it. X1, X2, Y1, Y2, and then you just kind of plug in what belongs there. Definitely going to be 2's down below. It's going to be something plus something else, something plus something else. And what are those points? Well, it's going to be -6 plus 8, and it's going to be 2 plus 5. So that is -6 plus 8. And then we have 2 plus 5. On the next line, we could sort of simplify that further. -6 plus 8 is 2. 2 plus 5 is 7. So we're looking at 1, 7 over 2. 7 over 2 is literally 7 divided by 2, also known as 3.5. Hopefully the teacher is cool with that. Okay, find the missing point given one endpoint and the other midpoint. Okay, multiple ways of going about this. A popular thing that teachers will do is they'll have you focus on the x-coordinates first and then focus on the y-coordinates after that. So here's sort of a logical way of going about it. From -6 to -2, you would have to add 4 to -6 in order to get -2. So we're going to add 4 to -2 to get the x-coordinate there. All right, so we're going to add 4. You know, we added 4 to -6 to get this. We're going to add 4 to -2 to get this. So that's going to be 2. And focusing on the y-coordinates, how do we get from 1 to -4? Well, we had to subtract 5 from 1 in order to get -4. So -4 minus another 5 is going to give us that. And -4 minus 5 is -9. I've seen it done before where it's like teachers will stack the coordinates where it's like -6 and 1, -2 and -4. If that's more comfortable, then just do it that way. And maybe even sort of like labeling it. It's like, you know, to get from -6 to -2, you would have to add 4. And to get from -2 to the next number, well, we're going to have to add 4 as well. And that gives us a 2. Similarly, to get from 1 to negative 4, we'd have to subtract 5, and we're going to have to do that again. We're going to subtract 5 again, and negative 4 minus 5 is negative 9. So that's a way of going about it. You can sort of set this up like that and just go down the line. Okay, that's how you do that one. Okay, find the perimeter and area. Sketch perimeter and area. Well, since we're going to sketch it, we might as well just kind of plot those points, right? We're going to sketch this thing anyway, so let's take a look. Okay, so we have negative 4, comma 1. That's going to be 1, 2, 3, 4, right there. That's one of them. Negative 4, comma negative 8. So that's going to be down 1, 2, 3, 4, 5, 6, 7, 8. That's going to be right here. And then we have 0, comma negative 8, which is right here. Okay, so we want the perimeter and the area. Okay, so this is a triangle. Okay, probably one of the harder problems we've done in this video because this one features the necessity of the distance formula. The good news is, we'll start with the perimeter. In other words, what's the distance all the way around the triangle? Well, this one's fairly easy. I mean, you could even count it if you had to. But at the end of the day, I'll just tell you it's going to be 1 minus negative 8, also known as 9. All right, so that's 9. And this is going to be 4. That's something that you could actually see. But the question is, what is this thing? And you will have to use the distance formula for that because this is slanted. This is a line that is not parallel to the x or y axis. So you're going to actually have to use the distance formula. And a distance formula is this. All right. Something, unfortunately, for my student, you're just going to have to memorize it in whatever way works for you. All right. It's usually x2 minus 1, y2 minus 1. Now, that doesn't matter. Whether it's x2 minus x1 or x1 minus x2, that doesn't matter as long as this matches that. Okay, if that makes sense. All right, and this matches that. So anyway, let's keep going. We're going to need the coordinates of this point. We're going to need to be super clear about it. And the coordinates of that point are, that is negative 4, comma 1. Kind of messy looking, forgive the messiness, and this one is 0, comma negative 8. So we're going to use the distance formula for that, and that would be, let's see, negative 4. Doesn't matter which one you start with, but there's going to be negative 4 and 0, and there's going to be 1 minus, parentheses, negative 8. So be careful with the parentheses. Remember, we are subtracting negative 8, right? Because that is this y coordinate. So you always subtract y sub 1. Y sub 1 happens to be negative 8, so we're subtracting negative 8. Just be careful with that. And we end up with, this is going to be negative 4 squared, which is 16. We're going to add that to 1 minus negative 8 is 9, and 9 squared is 81. And that ends up becoming 97, radical 97. So kind of a tricky number, kind of an ugly number. If you plug that into your calculator, you get some like decimal deal. But I'm just going to write the answer as being 9. Since it's the perimeter, we're trying to get the distance all the way around. Well, we found this distance. It's 9 plus 4. That's going to be 13 total, plus this other ugly number. So that's going to be 13 plus the ugly number, radical 97. The teacher might want an approximate, an approximation. So you might have to plug that into your calculator and figure out what the decimal is and then add that to 13. And then they ask for the area. Now the area of any triangle, this is a triangle, the area of any triangle is going to be 1/2 times the base times the height. And The base is this, and the height is that in this case, because it's a right triangle. So the base is 4, and the height is 9. So I like to think of it as 1/2 times 4. Well, that's just 2. So it's going to be 2 times 9, which is 18. So that's the area. All right, 18. And the perimeter is 13 plus radical 97. Okay, looking at the next problem. Once again, let's plot the points first. And we'll do one at a time. We've got -5, 3. And that is going to be -1, 2, 3, 4, 5, and then up 3, which is right there. We have 3, 3, which is 1, 2, 3, which is right there. And finally, we have -1, 5, so that's going to be 1, 2, 3, 4, 5, and then over because of the -1. So that is our triangle this time. Now, since we want to find the perimeter, we want to get all these side lengths. Let's get that taken care of right now. This is the side length that's the easiest to figure out because it's parallel to the x-axis, which means we only need to take into account the difference in the x-coordinates. You can also count it or eyeball it in such a way that, like, you can see that it's 5 here and then 3 there. So therefore, 5 plus 3, definitely 8. Unfortunately, for this one and this one, we're going to have to use the distance formula because this is a slanted line, this is a slanted line, and we're going to have to break out the distance formula. So let's do that right now. Well, we could get the distance formula ready at least, but I do want to take into account the actual coordinates. And the coordinates are, the top one is that -5, or -1 rather, pardon me. The top one is -1, 5, and this guy to the left is, that one is -5, 3. Okay, so filling it in, we're going to have -1 minus, careful, -5, and then 5 minus 3. And working that out gives us -5 minus -5 is really -1 minus -5 is really -1 plus 5, which is 4. And 4 squared is 16. So it's going to be 16 plus 5 minus 3 is 2, and 2 squared is 4. So what we have on our hands here is radical 20. So that right there, radical 20. All right, let's figure out what this distance is now. And before I do that, I'm going to get clear on which points I'm analyzing. Once again, it will be that -1, 5, but it's also going to be this point. So it's this point and this point. This point is the 3, 3. So I'm going to just write that down. And distance formula would be the following. -1 minus 3, and then it's 5 minus 3. And then we have on the next line, -1 minus 3 is -4 squared is 16, and 5 minus 3 is 2 squared, which is 4. So once again, we're going to have radical 20. And, you know, it kind of looks like it. It looks like it's actually an isosceles triangle. It kind of looks like it. Might not be terribly obvious to the eye, so I would advise doing the distance formula just in case. And anyway, we have the perimeter now. It's 8 plus these 2. And how could we represent that? Well, we could represent that as the perimeter equals 8 plus radical 20 plus radical 20. Or we could say 8 plus 2 times radical 20. That's a way of thinking about it. Now, the teacher might want you to simplify this radical 20. Teacher also might want you to just figure out the decimal version of this, and that's fine. If you want to simplify radical 20, that would become 4 radical 5. It is true that radical 20 is really equal to not 4 radical 5, pardon me, it's going to be 2 radical 5. So this is really, therefore, 2 times 2 radical 5, which you could therefore say the final answer is 8 plus 2 times 2 radical 5, also known as 4 radical 5. Once again, my student, I believe, strong possibility the teacher is just going to want the decimal version of radical 20 anyway, so I hope my student realizes all she has to do is just add all this up, really. The decimal versions of these if need be. Anyway, moving on. Okay, what are the sides of angle 6? Well, angle 6 is right here. Clearly, the sides are FW, GW, or you could say WF and WG. It looks like my student got that correctly, so this is kind of a fast video section right now because my student already got it correctly, but that's basically how it works. WF and WG, those are the two sides that, in a sense, compose angle 6. Moving on. Let's see, if M is the midpoint of segment AB, okay, so first of all, I'm just going to draw that. Okay, here's segment AB. Let's just get that over with. We know that M is the midpoint. Let's get that over with. And then AM is 7x minus 1, so that's this right here, 7x minus 1, and AB, the whole thing is 15x minus 12. What's the length of MB? Well, we have good news. We know that the length of MB is the same as the length of AM, right? And therefore, we could kind of temporarily represent MB as 7x minus 1, right? Because we know it's the same length as AM. And it's kind of helpful to just write that because then you could clearly see, even visually, and this is due to the segment addition postulate, you can clearly see that 7x minus 1 plus 7x minus 1 is going to equal 15x minus 12. So let's just write that. 7x minus 1 plus yet another 7x minus 1. That is going to equal 15x minus 12. All right, let's get the like terms. We got 14x minus 2 equals 15x minus 12. I see an immediate opportunity to subtract 14x from both sides, which would give me an x over here. So I'm going to do that. Subtracting 14x from both sides gives me an x. And I'm going to add 12 to both sides to give me a 10 over here. So x is 10. Now be careful. The teacher will try to fool you into thinking that, I'm done, x equals 10. But remember, what are they asking for? Find the length of MB. MB is 7x minus 1. So MB is going to be 7 times 10 minus 1, also known as 69. And you are done with that one. All right, name the angle, sides, and vertex. Okay, so different ways of writing angles. Here, this one especially for my student. Sometimes you're going to have angles with like a 6 in there. And then that's literally angle 6. All right, keeping in mind that this 6 doesn't represent the amount of degrees. It's literally just a label for the angle. So that's angle 6. Occasionally, though, you're going to get an angle like this that has these letters. And it's really important to recognize that there's a couple ways of representing this too. You could call it angle N because it can't be confused with any other angle. I mean, if we had some other thing called, S right there, we wouldn't be able to call this angle angle N because do we mean this angle? Do we mean this angle, right? So if it was like this, then you couldn't just call it angle N, but it so happens that we have a simple situation where if we were to call it angle N, we could get away with it because there's no other angle that this could be confused by. So I'm going to do a little asterisk here. There's really 3 different ways of correctly saying the angle. One is to call it angle N. Another way of calling it correctly, its name, is to call it angle R and T. Okay? The order matters. If you're going to do this 3-letter deal, then the middle letter needs to be the vertex, all right? And on that note, we could also call it TNR, okay? So actually 3 different possible ways of labeling this angle, I believe my student hopefully will understand that the teacher will likely accept any of those three. All right, sides. What are the sides? Well, we're dealing with two rays. We have this ray going, and we have this ray going. So for that one, we'll do a double asterisk. The sides are NR, and that is a ray, and we have NT, and that is a ray. Notice how the end point of the ray corresponds with the actual, end point of the ray, the letter, right? Okay, so that's important. Vertex. The vertex is a point. Well, what's the point? Triple asterisk. What is the point that corresponds with the vertex? Well, that would be N. Done. Okay. Distance and midpoint. Okay. Pure distance formula action. Let's write it because I know I'm going to be doing it. And what are the points involved? The points are the following. We got -8, 4. We've got 10, 7. Let's go ahead and get to work. It's going to be -8 minus 10, and it's going to be 4 minus 7. And what do we have as a result? Let's just do the calculations now. -8 minus 10 is -18. -18 squared is 324. And that's going to be added to, what is this? We have 4 minus 7, which is -3. -3 squared is 9. So on the next line, 324 plus 9 is 333. So we're looking at radical 333. Okay, so if we want to simplify that, we could always do a prime factorization of 333. 2 does not go into 333, but 3 does. And that creates 111. Now, I know for a fact that 111 is also divisible by 3. The way that I know is that a trick of the trade that's interesting in math is you can always know if a number is divisible by 3 by adding the digits. And if that sum is divisible by 3, then the original number is divisible by 3. When I add the digits, I get 1 plus 1 plus 1, which is 3, and 3 is clearly divisible by 3. So therefore, 111 is divisible by 3. So we have 111 divisible by 3. 3 goes into 111, let's see, 37 times. So what we have is this prime number, this prime number, this prime number. These are all prime numbers. So it is therefore the case that radical 33 could hypothetically be rewritten as 3 squared times 37. And whenever you want to simplify, radicals, it's good to kind of write it this way and ask yourself which bases, 3 is a base and 37 is a base. In other words, it's a large number at the bottom. Which bases have an exponent of 2? Whichever base has an exponent of 2, that's the base that gets out of prison. You could think of this as a prison cell. So 3 is the only base that's showing an exponent of 2. So therefore 3 gets out of the jail cell, and this poor 37 is left behind. Looks like my student did it correctly, so I commend her on that. Okay, midpoint. Okay, midpoint right here. We're just going to do it right here. That is this formula, once again, which I encourage my student and any student to memorize. X1 plus y, x1 plus x2, that's going to be -8 plus 10 up here. And we're going to have 4 plus 7 over here. And then at the end of the day, I'll squeeze it in over here. Let's take a look at it. -8 plus 10 is 2. And 2 over 2 is just 1. And 4 plus 7 is 11. And 11 over 2 is, you could call it 11 over 2, also known as 6.5, or 5.5 rather. But I'm happy with 11 over 2. And it looks like my student got that correctly as well, so I commend her on that one. And that is all she wrote for now. So hopefully that was helpful, and I will see you all next time. Take care.